Okay, so we're going to review some solving quadratics, and this is going to lead us to completing the square. But before we really do too much, we want to think of when we're solving equations, we're trying to get the letter by itself. We want to know what values will make the equation true. When we're doing quadratics, we're going to have stuff that is going to have an x squared. And our most basic quadratic would be x squared equals some sort of number. So if I say it is 3, if I wanted to solve this to say what numbers it would be, I could set it equal to 0 so that I can use my zero root property, or I could just say, I know I can undo because I've got the x squared completely by itself. I can undo the x squared by square rooting both sides. The thing that I have to remember when I square root, remember when I'm squaring something, if it's both of them are negative, I would still get a positive. Both of them are positive, I'll get a positive. So I have to account for whether things are positive or negative. So when I square root on a side that doesn't have the x squared, I'm always going to put a plus or minus in there. So then I'm going to think, oh, it could have been positives and it could have been negatives. The square root will cancel out with the squared because they undo each other. And then I would have x equals plus or minus. So there's two answers, the square root of 3. Okay, I can make things a little bit more challenging by making whatever squared a little bit bigger. So if I said x minus 3 squared equals 5, I could do the same thing that I was doing before, where I've got the squared term is all by itself. I have no other variables. I just have numbers or constants. So this whole thing is squared. It's where my x is. So I could do a square root of both. Remember, when you square root on something that doesn't have that, you want that plus or minus at least once. Whoa, what is happening? Okay, awesome. Uh, and then the square root cancels with the square, so you'd have x minus 3 equals positive or negative 5, square root of 5. And then you'd still try to get x all by itself, so you'd add 3 to both sides. And then you'd end up with x equals 3 plus or minus the square root of 5. So there's two answers. There is x equals 3 plus the square root of 5, and I can't combine them because one is a plain old number and one is a square root. And then x equals 3 minus the square root of 5. So two answers. I can usually write it shorthand with that plus or minus with that. So that's basic solving quadratic equations. If there is only one variable, it is all by itself, and I can get rid of that squared. So then, remember, we were doing some multiplying things, and if I gave you something like x plus 3, the number of my day, squared, I could follow a pattern. This is the binomial, perfect binomial square, where I square the first thing, I square the last, so plus 9, and then I multiply these two together and double it. So x times 3 is 3x times 2, so 6x. I could have FOILed it out, so that would have been x plus 3 times x plus 3. And if I FOILed it out, I would have gotten that 3x plus another 3x, so I would have had that. So we're actually going to look for, when we're completing the square, we are looking for these type of patterns. This is a perfect square trinomial. Okay, so we are going to be using this perfect square trinomial and using the basic x squared equals some number concept, or the parentheses of with x in it equals some plain old number. And it's going to make our life a little bit easier for solving some equations. So first thing I need to do is give us a quadratic equation to solve. And I'm going to give you one that we could solve by factoring as well. So we're going to start with an answer. And we're going to do x plus 4 and x minus 2. Okay, this is going to tell me that my answers, if I was starting with numbers, I want my x equals -4, x equals 2. So the roots, the answers that I'm going to get, I want to have x equals -4 and x equals 2. And if I'm going to put that into my factors, they end up changing the signs because we're using that zero root probability. If I wanted to solve this, this factor would become x plus 4 equals 0, which is where we're thinking about that. And I'm going to say this equals 0 because this is going to be my trinomial that we have. So we have x squared minus 2x plus 4x minus 8 equals 0. And this is x squared plus 2x minus 8 equals 0. So we're going to start. This is looking at where my answers are. So I know my answers will get to this. So it's kind of a backwards way of what teachers kind of can do. So my problem is going to be giving you this. The problem is going to be solve x squared plus 2x minus 8 equals 0. One way we could do it is factoring it, but we're not going to do that for this one. We are going to do completing the square, and our completing the square is going to have specific steps. I'm trying to think how I want to do this. All right, so I'm going to put this is, I know what answer I want to get. Okay, answer. So if what I have works, this would be an example showing how it works. And our steps for completing this square. Steps. The square. Now, there's going to be a few different ways people do this, but my way, when I'm starting this, is 1, get the x terms on one side, plain old numbers on the other. Constants on other. Okay, so for that, my constant in this time is -8, so I'm going to add 8 to both sides. So we're clearly not going to be using the 0 property, but remember, we're going to do that x squared equals and be able to square root stuff. So I have x squared plus 2x equals 8. All right, so that's the first step. Second step, to this pink. Step 2, if there's a coefficient, a lead coefficient, x squared has a coefficient. Divide everything by it. In this case, our coefficient is 1, so we're not going to divide anything. We're going to be using the property of whatever we do on one side, we do on both sides to keep things equivalent. This will show up in another example, but not this one. All right, step 3. So I have a plain old x squared. I have a coefficient on the x, and I have an 8. So this is nothing that I can solve exactly right yet. So I'm going to take the coefficient of the x. Okay, we're going to divide it by 2 and square it. Okay, because while we're doing this, we're thinking of, we wanted the opposite of what this was. We multiplied these two numbers together, and then we doubled them. And this number here was the square of whatever I had in the parentheses. So we're kind of working back to figure that. So we're going to first divide by 2. So I need the number I'm looking for. I'm going to put it off to the side. I have 2x. So this is going to be 2 divided by 2, which is 1. Okay. So I've got 1 that I need to do. 1 squared. I square that, and I have 1. So step, yeah, 4. Add this to both sides. Okay, so I'm going to go plus 1, plus 1. Okay, your left side should be a perfect square trinomial, meaning the number that you have on the left side should be a perfect square. If I multiply it times the first, or basically go 1 times whatever it was, because my lead coefficient is 1, and double it, I should have that middle term. So the left side should be a perfect square trinomial. And then we're going to write how we do perfect square trinomials. So 5 left side should be perfect square trinomial. Right as the binomial squared. We're going to do a few of these to look at this. So if I'm writing it as the binomial squared, I'm thinking of this example here where I had the x plus 3 all squared. I know that whatever this last term is, I need the square root of it in my parentheses. So my parentheses are going to look like this. I have the x, and everything is a positive. That middle term is a positive, so I know I have a positive here. And then what times itself is 1, and that is squared. So my perfect square trinomial is, I'm undoing when we were looking at those patterns for the factoring it. And then my right-hand side is 9. So the last step is solve for x. So step 6, which I'll do in gray. 6, it's out of line. I'm going to have to add a page. Solve using square root property. And I'm going to do plus or minus square root. All right, so I now have x plus 1 quantity squared equals 9. I'm going to square root both sides. Square root both sides with a plus or minus. And I have x plus 1 equals plus or minus 3. So I'm going to get x by itself. So I have x equals -1 plus 3. And I have x equals -1 minus 3 because I have that plus or minus sign. So 2 of them. So x equals -1 plus 3 is 2. And -1 minus 3 is x equals 4, which are those two answers that I started with looking at. So we're going to do some more of these. We're going to also do a very generic one so that we can see where the quadratic formula comes in. Some people like the quadratic formula, but a lot of people can't remember all of the steps or they make small mistakes with it. This kind of can simplify it as long as you can look for those patterns for those perfect square trinomials. Remember how those factor and solve for that. So that's the pattern that we're going to do. Okay, so I rewrote my steps so that they're a little neater to read. Hopefully, still my bad handwriting, but we can deal with that, hopefully. So the steps for completing the square are one, we're going to get the x terms on one side and the constants on the other. Then we're going to have, if the x squared has a coefficient, we're going to divide everything by that coefficient. Yes, we will have to deal with fractions, but they will be easier than dealing with factoring and stuff like that. And then we're going to divide the coefficient of x, whatever is in front of that plain old x number, by 2. And then we're going to square that and add it to both sides of the equations. Then the one side should be a perfect square trinomial, and we should be able to factor that, so we can write it as x plus something in parentheses squared. And then we're going to solve by using the square root property, which is when we square root both sides, we have a positive and a negative, and we're going to take square roots. So we have a new problem, and the problem is to solve x squared minus 8x plus 5 equals 0. My first step that I'm going to do is to get the 5 to the other side. So I'm going to have the problem I'm really working with is x squared minus 8x equals negative 5. So I'm just going to subtract 5 from both sides. So minus 5, minus 5. All right, so then I don't have a coefficient on the x squared. We will see that on another problem. And then I am going to take that middle term, which is my negative 8. I'm going to divide it by 2 equals negative 4. And I'm going to square that, which gets me to the 16. Negative 4 times negative 4 is 16. So I'm going to be adding 16 to both sides. All right, so this gives me x squared minus 8x plus 16. 16 is a perfect square. It's the square root of 4. Half of 4 is 8. Since it's a negative, I know that this factors, it's a perfect square trinomial, and it factors to x minus 4 squared equals negative 5 plus 16 is 11. All right, and then I can use the square root property, meaning I'm going to square root the left side, square root the right side, remembering my plus or minus. And then I have x minus 4 equals plus or minus the square root of 11. I'm going to get the x all by itself because I need to finish solving the problem. So x equals, add 4 to both sides. And 4 isn't under the square root, so it stays by itself. So equals 4 plus or minus the square root of 11. And that's my two answers. So my answers are 4 plus square root of 11 and 4 minus square root of 11. Okay, so it actually is a little quicker, I think, than quadratic formula, but that's partially because I'd rather do this than remember the x equals negative b plus or minus the square root b squared minus 4ac all over 2a, because there's just a lot of places we can make a mistake with that. So we're going to do a couple more examples. They're going to get a little bit trickier, and then we will do the generic one in just a few minutes. Okay, so this one is going to be the ugly one. It's going to have fractions. It's not going to work pretty, but it's what we're going to do so that you have a worst case scenario to look at. So we're going to first get the x terms on one side of the equation, numbers on the other. So the plain old numbers, that is. So I have 3x squared plus 7x equals 9. And I leave space because I know I'm going to have to add some stuff to it and eventually. So that's just kind of what I do. Now, if x squared has a coefficient, which it does, that 3, I'm going to divide everything by 3. It is not pretty, but some of it works. All right, so the 3's will cancel out. I'm going to be stuck with that 7 over 3, and then 9 will become 3. So my problem is now x squared plus 7 thirds, yuck, x, equals 3. All right, so now we're going to do some stuff with fractions, and I know we don't like fractions, but trust me, they're actually not as bad as we think. It takes a little bit of thinking. I remember when fractions started making sense, I was sitting in organic chemistry as a junior in college. So be patient with yourself. Fractions do eventually make sense. Divide the coefficient of the x by 2. So I have 7 thirds. So I'm going to do it right about here. So 7 thirds divided by 2. So this is going to be 2 over 1 because I like fractions. So this is the same thing as 7 thirds times 1 over 2, which is 7 over 6. All right, so that's divided by 2. Square this number. So when I square a fraction, I square the top and the bottom. So this is 49 over 36. This is what I'm adding to both sides. It is ugly. Plus 49 over 36 plus 49 over 36. This is insane. Now, I wrote that 7/6 that I had when I divided by 2 before I squared it. I wrote that out because I want to be using that because that's going to help you with my perfect square factor binomial, which is, I lost half of this, x plus n squared equals, did I say 0? Da, da, da. Oh yeah, that's it. All right, so I'm going to rewrite it. This is a perfect square binomial because I created it to become one. So it is going to become x plus, because it's a plus sign, and then the 49 over 36, that is 7 over 6 as a square root. And then this is squared, and it equals this ugly stuff. I can make it into a mixed, improper fraction. It's right now a mixed number, even though there's a plus sign in there. It's kind of ugly. Mixed numbers are hard to work with. And to get it into an improper fraction, the denominator will stay 36. And it is going to be 36 times 3. I will do it way down here. 36 times 3. If I'm thinking about that, that is the same thing as 30 plus 6 times 3, which is 90 plus 18. So this is 108. 8 plus 49, because I have to have the whole thing. I'm going to leave that for a second. I've got my perfect square trinomial. I have not simplified the other side, but that is okay. I'm going to square root and square root, and I have x plus 7 over 6 equals 156, 157, sorry. Never trust when I'm doing things in my head. 157 over 36 square root plus or minus. Now, with those square roots, I know 36 is a perfect square, which is actually kind of nice because it's the same denominator as what I had. So this is x plus, I might just move it over to the other side. X equals -7 over 6 plus or minus the square root of 157 over 6, which is really ugly. I don't think there's a perfect square hidden in there. We'll check it in a bit, but 9 doesn't go in there because if I add up the digits, 1 plus 5 plus 7 is not a multiple of 9. 4 doesn't go in there because it's not even. 5 doesn't add into 5, so 25 isn't going to work. I'm thinking I'm pretty good with what I have. So if I really wanted to simplify it, the only thing I can do is x equals -7 plus or minus the square root of 157 over 6. All right, so it's kind of ugly, yes, but it is still doable, and it would be just as ugly if I used the quadratic formula. All right, so there are going to be, I can do more of them if needed. I'll probably put another video. I just don't want this one to become too long. I do want to show you where the quadratic formula comes from. So remember, if I have ax squared plus bx plus c equals 0, this is a quadratic equation in standard form. And it's the generic formula. So if I were to follow the steps that we have, we're going to first move that c to the other side. So I would have ax squared plus bx equals -c. All right. And then we're going to divide everything by that coefficient of x squared. Okay, so then we have x squared plus b over a x equals -c over a. Now we're going to do off to the side that middle term, b over a divided by 2 is the same thing as b over a times 1 over 2, because that's C change flip, equals b over 2a. If I'm going to do b over 2a squared, I'm going to get b squared over 2a times 2a is 4a squared. That's what I add to both sides, plus b squared over 4a squared plus b squared over 4a squared. All right, so that gives me x plus b over 2a equals, now, if I want these to be added together, I'm gonna first I'll write out what we have, but then we gotta leave some space for some getting common denominators. So I'm gonna put the positive first, so, well, doesn't really matter. B squared over 4a squared minus c over a. If I need these to be common denominators, this is going to need a 4 and an a, and whatever I do at the bottom, I have to do the top. So this gives me, forgot my squared, x plus b over 2a squared equals b over 4a squared minus 4ac over 4a squared. Okay, so far, so good. Working on solving this some more, I can get this into one fraction, which is b minus 4ac over 4a squared. And I have the x plus b over 2a squared. So I'm going to square root, remember plus or minus. So I have x plus b over 2a equals plus or minus the square root of b minus 4ac over the square root of 4a squared. Okay, I'm running out of paper, but that's okay. All right, so then I'm going to subtract that b over 2a. So I have x equals negative b over 2a, subtracting it, plus or minus b minus 4ac over the square root of 4. This is one term underneath here, so I can square root everything because it's all perfect squares. Square root of 4 is 2. Square root of a squared is a. All right, denominators are the same. I could leave it like this, works perfectly fine. Or I can rewrite it as one fraction because the denominators are the same. So this is x equals negative b plus or minus the square root of b. Where did I list the squared, I think? Oh yeah, because when I was adding this, I forgot my squared up here. Awesome. Don't let me do that. There's a squared. Typo. This is why it's complex. B squared minus 4ac all over the 2a is the denominator. So this is quadratic formula. All right, so that's just a few examples. We will try to put together some more, but see if this helps you. These are the general steps that I use when I'm completing the square. Hopefully you won't have many with the coefficient at the front. It is one way to solve things that doesn't require factoring necessarily. It might get you to real numbers. It might get you to other stuff. So that is completing the square and then deriving the quadratic formula from it. So completing the square just means we're going to get down to those answers. So we will give you some more in a bit.